Okay, so I left off, we were right about here at climate. So climate is a region's general conditions over long periods of time. This is where we're talking about average temperatures, average precipitation. What is your latitude? So the equator is warmer than at the poles. Um, sorry. Sorry about that. This is my daughter. She wanted to make sure her presence was known here. All right. So the equator is generally warmer than the poles. If we are in tropical regions, we end up having a lot of moisture. Arid regions, we are very, very dry. These are all things that are our climate. The Earth's axis is actually tilted at a 23.5 degree angle, and what that means is that the northern hemisphere gets more direct sunlight during our summer, southern hemisphere more direct sunlight during our winter. Our Earth does wobble some as it goes around the sun, which does cause some other issues as we get into different parts of our climate and our patterns. So we do have atmospheric circulation. Okay, so at the equator, not a lot of wind. The hot air is just simply rising up. Okay, it goes up, it travels about 30 degrees, both north and south, and then it falls. Okay, it's lost its moisture, it's gotten cold, it falls down right around the 30 degrees latitude, and then it either goes towards the poles or it goes back towards the equator. So it kind of comes down, splits. Same way as with the warm air, it rises, it either goes north and south. So the warm air, basically it rises up at the equator, it falls down right around the 30 degree latitude, both north and south. And then it can either go towards the pole or back towards the equator. As it goes towards the poles, between 30 and 60 degrees, it then rises, and then it falls at around 60. Now, because the Earth is rotating, we have the Coriolis effect. So the Coriolis effect is basically that the wind is getting deflected, or it appears to be deflected as it is rotating, because the Earth's rotating, we're standing on the Earth. If you're in the northern hemisphere, it seems like the winds are going towards the right. If you're in the southern hemisphere, they're going towards the left. And there's those 6 cells that are making those little circles that are affected by this Coriolis effect. Going through, there is atmosphere and ocean interactions. Basically, the heat from the sun hits the water, causes a lot of evaporation. We have a lot of evaporation. That water vapor then goes up into the air. And what that does is it transfers a lot of moisture and heat from the ocean into the atmosphere. This happens a whole lot near the equator, where we have a lot of that heat hitting. And this is one of the reasons why we end up seeing things like hurricanes, etc., being born near the equator. Different climates and vegetation, we get those in different places, mostly because we have not only the warm and cold air, but also the warm and cold ocean currents, which then, if we have a warm ocean current, for example, the warm ocean current that runs along the side of the eastern seaboard, it causes us to have warmer temperatures than areas that have the cold current running along their coasts, even if we're at the same latitude. It ends up redistributing that heat from the sun. Europe would be subarctic if you look at it on the globe. It's about the same latitude as Siberia. However, because it has that warm ocean running next to it, we end up having the more temperate climate there. The ENSO, okay, this is the oscillations that occur. You'll hear them referred to as El Nino and La Nina. These, we'll get more into that when we talk about water, but they're very much affected by this atmosphere and ocean interaction here. When we have the El Nino or Southern Oscillation, the westerly winds basically stop going, and the surface water ends up warming along the west of Americas instead of being cold, and we end up not having the cold water that's actually usually pushing its way up along the west coast. We get what we end up seeing there is we end up getting less productivity of fish. We also end up seeing fewer hurricanes in the Atlantic when this occurs. And that's just one of the ones. We'll get more into the NSO with our global water. Right, so this was our second part of the atmosphere notes. Sorry about all of the fussing my daughter is doing, but that should finish it up.